area between curves, there are two cases. So the first case is dx integral, where you have a vertical rectangle. I will explain all of those in this video. And then the next case is using a dy integral, where you have a horizontal vertical. So let's take a look at case 1. So area between curves. So before this lesson, we studied the area under the curve, and then we have function, right? So let's say the function is f of x, and then we say the function is defined between x equals to a to x equals to b. And then I am interested in finding the area under the curve. So you do a definite integral where x goes from a to b, and then f of x dx. So basically you integrate the function, and then you use the fundamental theorem of calculus, plug in b, plug in a, subtract them, you get the area, right? So in this lesson, we are going to take a step further. What about area between two curves? So let's look at the picture on the left. So we have two curves. So the first one, I use different colors for each graph. So the first one, we have a pink curve, so that is the function f of x, and then we have a green curve, that is function g of x. I am interested in the total area between f and g, where x goes from a to b. So let's take a look at the region above the x-axis. So in the picture, do you see that there is a pink region? I call that region A above the x-axis, and there is a region B, which is the green region below the x-axis. So we studied this in the previous lesson, where the area above the x-axis is positive, the area below the x-axis is negative, right? So if you are looking for area A, so let's look at the right. So area A is equals to the integral of f of x, x goes from a to b, dx, that is equals to positive area, right? Because the area is above the x-axis. What about area B? So the area B is the integral x goes from a to b, gx dx, and that is equals to negative. So we have two pieces, one above the x-axis, one below the x-axis, one positive and one negative. What is the total area? The total area is, you have to look at the notes below the graph, that is the blue handwriting. So that is the total area, which is equals to region A plus region B, which is, now listen, you take a positive number and then you add to another negative number. So basically, let's say, for example, the area above the x-axis, so for region A, we have the area equals to 10, and then region B is below the x-axis, the area is negative 4. So just for example, okay, just give you a number, so that helps you to understand the concept. I have top plus the bottom, right? So which is 10 plus negative 4. So that is equals to 10 minus 4. How do we go from plus minus to a minus? Because we have a plus minus, that is just a minus, right? So if you take 10, you add a negative 4 to it, that is the same thing as saying 10 minus negative 4. So that leads me to another step, where the total area is the top curve minus the bottom curve. So if you follow the arrow, do you see that I wrote total area is equals to top curve minus the bottom curve? So that's how we get the first concept. So when you look for area between two curves, you use the top curve minus the bottom curve. But how do you know which one is on top, which one is on bottom? There are two ways to answer this question. First, you look at the area. You can clearly see which curve is on top, which curve is on the bottom. You can see it. You can use your eyes to see it. The second way to explain this is you will be using a rectangle, which is the next stage. But before we go to the next stage, let's take a look at the integral first. So the total area is the top curve minus the bottom curve. So that is equals to the integral, definite integral, x goes from, oh, that should be x goes from a to b, right? So I make a little mistake right here. So x should be go from a to b. So x equals to a to x equals to b. So we have the top curve minus the bottom curve, top minus bottom, and then dx. So you take one function minus the other, and then you integrate that using whatever method is feasible, and then you plug in b, plug in a, subtract them using the fundamental theorem of calculus to find the area. So the result of this definite integral is the area between two curves, right? So that is the total area. But what about the rectangle method? So if you look all the way to the top, do you see that I wrote vertical rectangle a dx integral. You have to keep this in mind, vertical rectangle dx integral. But where is the vertical rectangle? So the vertical rectangle, you can see that on the next stage. So I have the same graph again, same graph, and then where is my rectangle? So rectangle, first I take a point that is on the top curve. So do you see that there is a yellow point on the top curve, and then there is another point on the bottom curve, and then we can draw a straight line to connect these 2 points, right? So what is the length of this line? How do you measure the length of this line? You use the top curve minus the bottom curve. Why do you use the top minus bottom? Another way to explain this is, do you see that the point on top has a y value? The point on the bottom has a y value. What is the distance between these two y value? You use the top minus the bottom. Let's say the y value on top is y equals to 4. The y value on the bottom curve is y equals to -2. Then you use 4 minus -2 to measure the distance, which is 4 plus 2 equals to 6. So there are 6 units between these 2 points, and which is the height of the rectangle. So using the language of the entire, not the language of the entire curve, using the function, not just one pair of points, using the entire function. So every time I draw a line like this, so let's say I move to another place, a point right here, a point right here, and then you connect them. Do we agree that when you look for the height of a rectangle, you always use the top minus the bottom? Yes, right? So when you look for the height, you use the top minus the bottom. So the whole concept, I wrote that right here, so you don't have to, catch my words as I say them out loud. So we use the rectangle. Some textbook, they call that the strip. Strip means one rectangle. The rectangle concept. So one rectangle, what is the area? The area is the base times the height, right? So the base is delta x. How do I get delta x first of all? So delta x, still we remember that when we do the Riemann sum, we use the upper limit minus the lower limit, which is b minus a, and then you have to divide it by the number of intervals that you would like to use. The more is better. Remember that? If you don't remember this, you have to go back to watch 5.1. The max minus the min divided by the number of intervals you want. So the result is equals to delta x. That is the base of one rectangle. And then the height is function f minus function g. So the area is f minus g. You get the height, and then you times delta x. Then that gives you the area of one rectangle. So let's say we want to use 4 rectangles to approximate the entire area. Then you use f minus g, which is top minus bottom. So top minus bottom, which is, so let's say x is equals to 5, then we use f5 minus g5. Again, this is one rectangle only, to calculate the height and then multiply the delta x to get the area of one rectangle. So since you have 4 rectangles, right, and then you do this for these 4 rectangles, I am sure that each rectangle has a different x value. So maybe f of 5, f of 4, f of 3, f of 1, whatever the value is. So you get 4 rectangles, right? You add them up, then you get the area. So this is the concept of case 1, vertical rectangle, where you have to use the top curve minus the bottom curve. The integral is a dx integral. So if you understand all these concepts, then you don't have to go to a book and then just follow all those string symbols. So if you can understand this, then you don't need to read the book at all. Okay, so to understand better, we have to use a simple problem. So we have a simple problem right there for you. So what did I do right here? I have 2 functions, a pink function and a green function. So the pink function is f, not pink, purple, whatever you like to call, is f of x is equals to the cube root of x. So that is the graph. And then g of x is the reciprocal function 1 over x. And then I use another vertical line, x equals to a. So once I cut the graph using x equals to a, do you see that these 3 lines, do you see that there is a region bounded by these 3 lines or curves? So I wrote area, right here. So there is an area bounded by, or you say there is a region bounded by these 3 lines or curves. Now, my question is, how do you find the area? So this is what? First of all, how do we know that this is the vertical rectangle? So here is how. We pick a point right here. And then there is another point right here. So what is the distance between these 2 points? You use the top curve minus the bottom curve, which is f minus g, right? So the rectangle is this, just like the midpoint rule. So you draw a point, and then you draw a line like that, and then here is your rectangle. So what is the top curve? The top curve is, if you don't want to use f of x, then you can do y equals the cube root of x, and then the bottom is y equals to 1 over x, and then this is from where to where? From x equals to a back to where? Back to here, right? So this is x equals to, what is that x equals to? Usually if the problem has a graph, they will give you the intersection point. If they don't, then you have to get it yourself. So the way you get this is you set them equal. So you have the cube root of x equals to 1 over x. All right, and then what do you do? This is x to the 1/3, right? That is 1 divided by x, and then you multiply x on both sides. So this side is equals to 1, and then 1/3 x to the 1/3 times x to the first, so 1/3 plus 1, so that is x to the 3 over 4. Okay, and then how do you know that? How do you solve for x? So what you have to do is you have to take both sides raised to the 4 over 3 power. And then you can clearly see that x is just equals to 1. And also x is equals to -1. X is equals to -1. Do you know why? Because the g of x is 1 over x, right? That is a reciprocal function. There is another piece in quadrant 3. So in quadrant 3, that creates another intersection right here, like around right here, where x is equals to -1. But we don't care about that region because we only concern about the region bounded by those 3 curves. Okay, then this is x equals to 1 then. Then x is from x equals to 1 to x equals to 8. Now we need to set up the integral to find the area. So the area is equals to integral x goes from 1 to x equals to 8, and then you have the top curve minus the bottom curve minus 1 over x, and then dx. So in this video, I'm not going to evaluate the integral for you because I'm pretty sure at the point you have made it to this lesson, at this point, you must know how to evaluate the simple integrals. Right, so that is how you find the area. Oh, by the way, when you take an exam, especially an in-class exam, the problem can be set up but do not evaluate the integral. So your job is you have to set up this integral. But when you see the graph, don't rush to the integral. Do some setup, find out the top, the bottom, and the intersection, and then use all this information to set up the integral. Don't jump right into the integral. And one more tips. When you draw a graph, make sure the graph is nice and big. If you make the graph so small, you will just confuse yourself. Alright, so that is the end of this lesson. In the next video, I will show you more example of using the vertical rectangle and setting up a dx integral. Alright, I see you all in the next lesson. Signing out for now.